Hey everybody, today we will do another video, and today we will do a video on a new software. Well, I guess it will be partially new because it's part of MATLAB, but it's called Simulink, right? So 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 this is MATLAB, the regular MATLAB. So Simulink is this little, you can see the little icon here. It says Simulink, right? So you click in there. And then from there, you get this, right? So here you can actually find some templates, right? And generate code, all that stuff, right? But in this case, we open a blank template, right? So as you can see that I have a blank template. Now, this is the little symbol that you click on to look for the tools that we need, right? So we click in there, and we click on. You can click on Simscape, right? But sometimes you can find a tool without going through Simscape. But Simscape is the one that has the electrical tools, right? So we can do couple different things that we need. We need Power GUI. So Power GUI. Right, so we need Power GUI. We need that, right? Then we can actually look for voltage. We can look for voltage. Control voltage source, and we select the control voltage source, which is this one right here. Right? There's two ways that you can do this. You can actually click on it and select untitled or whatever name you name it on the project, or you can just drag it to the project. So either way it works. Now I can look for other tools I need voltage measurement, right? And then we need current. So what I was saying is you can actually do like this, right? So here, right click and add block to model untitled would mean that I don't have a name for it yet. And then you will do that, right? So now I need a signal generator. Signal generator, and right click, right, and add it to that, right? So now I need scope So, and we, of course, we need more of this, but we can make a copies out of this, right? So then I need the elements that I need, right? For the circuit. So in this case, we will be doing it will be like an AC analysis, right? With capacitors and inductors, which will be an RLC circuit, right? So we type RLC, right? And here we have a couple different options. We have a parallel RLC load. We have parallel RLC branch. We have parallel. We have a series RLC branch. So this is the one we need, right? So, okay. So I think we have the element that we need. We just need to make some more copies, right? Stuff that we need, right? So actually, do I need single generator? Okay, so this is a power GUI. This is the one that allows us to actually connect these devices. So we connect that single generator to the voltage source. Then we come over here and make copy of this. So make couple copies. Right. So in this case, notice that I have, let me just select that and Control R, and that will rotate. Right. So, and I had another generator back here. It's weird that I was looking for that. I didn't see it, but anyway. Okay, so in this case, what I can do, as you can see right here, that I have a resistor, inductor, and a capacitor, right? So I will click on it and then go to RLC, drop down and select the R, right? And that will select the resistor, and let's put that 1,000 ohms. Right. Then do the same thing here. Select. And this is going to be the inductor. So select L. Right. Then right here you can put 100 millihenries. Right, 100 millihenries, and okay, so here I do a capacitor and I put just change that to nanofarad. So I got 100 nanofarads, right? So now I can just wire this. I can wire those. So, right, and then I can just wire that, come over here, and wire that, right? Now, so now I have, look like a circuit, right? I can come over here and let's say that we want to generate a square wave with an amplitude of 2.5 and a frequency of 100 hertz. Right. So now what I can do is to do something right here. Let's see. So here, oops, I don't want connector. Okay, so now, all right, so now I can make another copy of this, paste it over here, and I need another copy here, right? So in this case, I can actually just go ahead and connect that, and I can actually connect this okay, so I need to make another copy of this and just copy here, paste it, I'm sorry, paste it here. And so in this case, I need to connect this. Right? So let's connect that. Right. So now I have it disconnected, right? So what I can do at this point is bring this so now I have this, right? So this is connected, right? So now right, something like that, right? Now this can be connected to that. Bring it up a little bit. And of course that can be connected to that, right? So with that being said, now we can change this value to 1. and we can set up the parameters, configuration parameters. And we have a step of 1. We have we can use this one, ODE23, and mod, stiff, right, and trapezoid, and I think that will do it. Let's see, let me just see, configuration parameters, and yep. So let's run it and see. Okay, so I did not see any red stuff, so I guess it ran. Okay, you seem like we're getting something. And it looked like we're getting a square wave, right? So what I can do, and that is the voltage of the capacitor. Notice that it is pretty much like in a square wave. So with that being said, that means that it's almost like a critical damping. So, and I cannot go through all that stuff right now, but I just, maybe eventually I will do a video on it, between all the critical damping and under damp and over damp. But for the meantime, we can actually just see that it's indeed a square wave for the capacitor. And as you can see, that is creating a square wave. But at the same time, if we increase this, right, you can see that it's coming up and then squares, right, and then goes down and so forth and so forth. But you can see the little shape right here is changing. So it's getting to that DC. So it's squaring the signal. Sorry, this is just squaring the signal when the changes of this is happening right in the signal, which technically that will be when the capacitor is reaching some certain amount, some value, right, and reaches the charge, right, and then it stays constant, right? The charge is staying constant, and that's why I said it looks like a DC, because a capacitor, when the capacitor fully charges, it looks like a DC source, right? So at this moment right here is some change, and we can actually see now that the changes start getting different, but it's look like a basically a square wave. Look at that. So okay, so we did that. Now let's do the now let's do, so we did a capacitor. Now let's do the current. And you can see that the current, let me just, okay, and let me just kind of work this out. so we can actually see it. Okay, so as you can see that the current, it spikes up immediately, right, and then comes down, right, and the system kind of goes down immediately and get that equilibrium again, and so forth and so forth. So yeah, so basically this is the current, the signal for the current. And let me just do the resistor, the voltage for the resistor. And the voltage for the resistor, you can see that you can see that the voltage for the resistor is also spikes up. See? So see that. So this is the voltage for the resistor value, right? So yeah, so that's how we do this is how we do this systems in using Simulink. It's a very good tool, actually. You can analyze, and you can do a lot of stuff here. So you can change, like for example, you can change the values of this. Let's say, for example, you want to do 4 millihenries, and you want to change the resistor value to 10 kilo ohms. And of course the value is going to change. So the graph is going to change too. You can see right here. You can see that now for the capacitor is not as a square, right? So you can see that. See that? So the systems start changing. You can see that. See that? Now it looked like a sinusoidal, almost. Not quite though. You still get that. But yeah, so it's getting that shape. So basically, it's supposed to be in a square, right? But the square is all depend on the values too, right? So you can see that. See how this is changing? So now it's taking longer to charge, right? Yeah, taking longer to charge, which means that that the system will be taking longer to get to that to get a stability, right? So, and I will do another videos about what is critical damping and all that stuff eventually. So you have a critical damp, you have under damp, and you have the over damp, right? So yeah, so this has been for today, guys. Hopefully you guys like this video. If you do like this video, please give me a like. And this is awesome. I think it's a good learning. I mean, I think it's a good tool. And I just love it. I love this type of systems, like this type of softwares like this. So basically, that's it, guys. Hopefully you guys learned something, and I will see you in the next video. Thank you for watching.